Alright, how's it going, guys? I'm Mr. Middleton here. Today we're going to look at simplifying radical expressions with variables. Okay, the rules don't change very much, if at all, but it is a different thing, saying letters and taking factors of those. Okay, so we'll break down the first one a lot, just make sure that we understand what's happening and that it follows the same rules, and then after that we'll kind of just go with it a little bit more smoothly. I'll look at a shortcut with the first one, and then you can handle the rest of the examples how you want to. Okay, so follow along. I think that if you got the last lesson, you should be alright with this one as well. Okay, so let's just jump into it because nothing changes. So we have radical 45 a to the fifth. Okay, now we have this variable here, and how I deal with variables usually is I kind of just separate them. So yesterday I told you how we can do the multiplication property to separate our radicals. I'm going to do that here. Okay, so I have radical 45 times radical a to the fifth. You know that's the same thing. Okay, now I'm going to deal with this radical 45. Two numbers that multiply to give me 45 are 5 and 9. 5 is a prime number. 3 is a perfect square. And so if I was just dealing with this, I'd have, well, actually I'll just keep that here. Okay, I have these values, these factors. Okay, a to the fifth, I have a. I'm not going to do a tree here, okay, because a to the fifth is just a 5 times. I have a times a times a. Excuse me. Alright, 5 times. So underneath my radical, I have 5, 2 3's, and 1, 2, 3, 4, 5 A's. Okay. And same rules, you gotta have a date to leave the house. 3's will go on the outside. I have 1, 2 pairs of A's that get to go out. So on the outside I have 3 A squared, and left inside is 5a without a pair. Okay. And that's my final answer simplified. So simplified radical. Alright. Now like I said, I'm going to show you a shortcut because if I give you a to the 12th, I don't want you to have the right 12 a's. Something you should notice here is we could divide this number to find out how many pairs we have. We could divide it by 2. 5 divided by 2 is 2 with 1 as the remainder. Okay, 2 remainder 1. So 5 divided by 2 is 2. That's the number of our exponent. Remainder 1 means we have something left in here. Okay, so let's try that on the next few. Alright, so I've got 27 and n squared. 27 breaks down to 9 and 3. 3 is prime. 3 is 3. So I have underneath my radical now 3 times 3 times 3. N squared. I have 2 n's. I wanted to do that. My pairs, I have a pair of 3's, a pair of n's. So on the outside I have 3n, and then remaining is the 3. Again, n divided by n squared. Squared divided by 2 shows me how many pairs I have. I have 1 pair. It goes out there 1 time. Okay. If you get it, you can stop now and just see how you're doing and check my answers. If not, keep following along. Okay. In this case we have a negative a on the outside, so we'll keep it there. Okay, let's see. 6 and 10 is what I'm thinking. 2 and 3, those are prime. 5 and 2, those are prime. Okay, so I have a pair of 2's. Go out. A to the 7th, I don't want to write a 7 times. So 7 divided by 3 is, 7 divided by 2 is 3 with 1 remainder. So I know I have a cubed on the outside. So I already have a negative a on the outside. I'm bringing along with it a cubed. I have a pair of 2's, and I have 5 and 3 that are left inside. 5 times 3, which gives me 15. Okay. So my answer should be, I'm going to write it up here because I have space. I'll write it up here. My answer should be negative, oh, nope, I don't have space. I'm going to write it up here. Negative 2a to the 4th radical 15. A, because I had that remainder 1. Okay. Number 4, both variables, p squared divided by 2 gives me p. R to the 5th divided by 2 gives me r squared, and there's 1 left over. That was easy. Last one. You try this one on your own, bring it back to me. Okay? And we'll see how you do. See ya.